is Nur Aisha. So I am Munirah will be present about question 2. So question 2 states that the combination of the perimeter of a circle and a square is 16. So we need to find the dimension of the square and a circle that minimize the total area. The first step is to define the variables used to measure the dimension. So let us use x equals to square side length and y equals to the radius of the circle. So we can get equation 1 from the perimeter. 4x plus 2 pi y equals to 16, and equation 2 from fxy equals to x squared plus y squared pi. Step 2, we can solve for x from the equation 1, 4x plus 2 pi y equals to 16. So we can solve for x, we can get x equals to 4 minus 0.5 pi y.
So hi, my name is Munirah. I will continue explanation for step 3. In step 3, we will find the function to minimize in the form of gy, which is 4 minus 0.5 pi y squared plus y squared pi. So we will get 1.25 pi squared y squared minus with 4 pi y and plus 16. And then for step 4, we use equation y equal to b over negative 2a, and then we get y equal to 3.2 over pi. And for step last, we substitute y into the equation of x equal to 4 minus with 0.5 pi y. And then we get the answer, which is 2.4 inches. For the side of the square. And that's all for the solution explanation for question number 2.
Assalamualaikum warahmatullahi wabarakatuh. My name is AIQAL and this is my friend HUSNIYAH, and today we will present the solution for question 3. The question is, show that the area of rectangle as illustrated in below the photo is the largest if x equals to 2 times to Z2 unit and y equals to 2 times to Z2 unit. So our first approach is to create a y equation from the Pythagoras theorem, because we can form a triangle from the illustrated rectangle. Then substitute y in the area formula and area in terms of x and r. Next, we differentiate the area a and equal to 0 to find the value of x, which is r over square root 2. And lastly, find the y value by substituting the x value into the theorem Pythagoras equation and also got r over square root 2. From the equation, x and y equal to 2 square root 2, and by substituting the value into the area equation, we can get 32 units as the area of the square. By using 32 as the area for 4xy and substituting r over square root 2 for the x and y values as we optioned before, we can obtain the value of r, which is 4. Okay, so now I will pass the presentation to the HUSNIYAH to continue the explanation. Thank you.
Hi, my name is HUSNIYAH. I will continue the explanation. Now our approach is to prove that 2 square root 2 for x and y is the maximum value. Now we have the area as 32 units, the radius as 4, and the value of x and y as r over square root x. Then, we obtain the r value, which is 4, we can substitute it into the theorem Pythagoras and get y in terms of x. We will obtain a prime in x term, which is 64 minus 8 x power of 2 over square root 16 minus x power of 2. we will obtain a prime in x term, which is 64 minus 8x power of 2. Limit x to the range 0 lesser and equal x, which is x lesser and equal 4, since we assume x in the first quadrant. We get critical points when both the numerator and denominator are equal to 0. When the numerator is equal to 0, we obtain x as plus minus 4. And when the denominator is equal to 0, we obtain x as plus minus 2 square root 2. The critical point must be in the range of possible optimal values, so that means there are two critical points to deal with, which is x equal to 2 square root 2 and x equal to 4. Then we substitute both possible x values into the area formula. What we can see here is that when x is 2 square root 2, it will obtain 32 as the result, which is the same as the earlier we tried by using the given x and y values in the question. But when using 4 as the x value, we will obtain the area as 0. So we can see that we will get the maximum area if x equal to 2 square root 2 and y equal to 2 square root 2. So the y value is 2 square root 2. There, it looks like the maximum area that will be found in the inscribed rectangle is in fact a square. Thank you.
So next is question 4. So the question is, we need to show that the closest point on the curve below to the point coordinate 1, 4 is 2, 2. So without further ado, let's move on to the working steps. Okay, so from the equation given, which is y squared equal to 2x, you need to rewrite the equation, which is x in terms of y. So it will become x equal to y squared over 2. And then you need to find the distance between the coordinate 1, 4 and xy. So the equation will be dy equal to square root x minus 1 square plus y minus 4 square. And then you need to substitute x equal to y squared over 2 into dy equation, and then it will become square root y squared over 2 minus 1 square plus y minus 4 square. And then I eliminate the square root, which I will square both sides of the equation, and it will become d square y equal to y squared over 2 minus 1 squared plus y minus 4 squared.
So for the next step, we must differentiate the equation of d square y and equal it to 0 to find the value of y when the minimum is a curve. So we must differentiate this equation by using chain rule, and we will get 2 times y square divided by 2 minus 1 times y plus 2 times y minus 4 equal to 0. After that, we must simplify the equation, and we will get y cubed minus 8 equal to 0. After that, we must find the value of y, which is y equal to 2. Move on to the next step. To find the value of x, we must substitute y equal to 2 in the equation x equal to y squared divided by 2. So we will get x equal to 2. So we can show that the closest point of the curve to the point 1, 4 is 2, 2. So I think that's all from us. Thank you.